We have a question from Stephen Lee earlier in the chat and live stream. And please ask Mr. Kesh about the counter-rotating magnetic fields and how they relate to the use of GANs in the dynamic reactors.
The counter-rotation of the fields comes in respect to the other fields within the vicinity of that field. We have explained this before. In the original reactors which we developed, we could see it when we have a dome. You see the Iranian nuclear-based system. The inner system rotates anti-clockwise, and we just change some parameters on the field strength. The system stops, and then it starts rotating the other way. So the direction of the rotation, as we have explained in the universe, is dependent on the effect of the environmental magnetic field pressure on the entity. It depends on the strength and the position. If you have a sun here with, let's say, with strength of 10 and a planet here with a strength of 1, this might go anti-clockwise. But if you bring it to the same 3 and here 1, now the field might change. It's the same planet. This is, you see this if you test it. You know the ring magnets, if you take and you bring the ring magnets together and you can play free ring magnets. Playing free ring magnets is not very easy. But if you can do it, you see the field forces are that way. And if you come very close, suddenly the field forces become this way and this one flips. It starts going anti-clock, and the push to be clockwise, it flips it, and then it gets attracted, become magnetic. So here they were comparable. If you see the field forces are rotating in according to what it is. But once you bring it close, it's the gap closure of the field transfer. It's just that if you're sucking in or you're blowing out. And at a certain point, you cannot suck in anymore, you have to blow out. And this transfers the energy field. This has been written in one of the books, and some experiments we explain clearly. It's strength and position dependent. If it's the same strength, but the position changes closer together, it's the gates of the fields, they have to go somewhere. Very simple to understand. If this field comes through and all the magnetical has gone, it's gravitational which is taken over. So now it pushes everything backwards. And if you go further back, it's a space gap to go. This goes back to one of the original teaching, original teaching. And I explained, if you go back, that there's a North Pole and the South Pole. Sorry. Let's clean it and start again. You have the North Pole and the South Pole. There was a theory that where does the field change? Field doesn't change anywhere from magnetic to gravitational. It's the same field. It depends on the position of the observer. And then it goes back again if you take two rectangular magnets. If you have two exits, what happens? They push against each other. These fields have to go somewhere. They cannot enter because it's different strength gap. It cannot go. It's too fat to go between the two. What does it do? They bend to field open. The other magnet moves back, and you find the separation. It's the same with if you take a South Pole. If you take two South Poles together, what happens to you? This is a South Pole. You have two entry, we call it. Yeah, they want to suck in as much fields from the universe as possible, but it cannot be done. What do? One moves further back, that both are satisfied. So two similar poles move away. That's the only reason. Depends where you are. Here they want to get out. Here they want to get in. So the fields always are the same, and in repulsion or attraction, they're trying to absorb. But what happens when you put a north and a south together? I'm coming out. I'm prepared to accept. So we get together. is understanding the new definition and the truth about the field motion. And then you understand certain points when the two have to adjust each other, but they carry a strength of the two, they position or they become anti, and it rotates and becomes either gravitational to magnetic. It's the same thing with the space gap. It's the rotation of the fields. You have both going from exit to entry, and then now you decide on space gap distance. If these two fields can be met, you get the gap. If it cannot be done, it goes the other way. Now you have a space gap this way. So it changes rotation. That's all it is. It's the same North Pole, South Pole, entry, exit. You call this one clockwise motion, you call that one anti-clockwise motion. But the rotation of the anti-clockwise or clockwise, it depends on the field strength of what's in front of it. And this is what nobody ever understood about positrons and others, they call it. Now we understand. Get yourself a magnet, 2 ring magnets, and play the game, you see it. The problem is we are introduced from the original, the first time, with rectangular magnets. And this is one of the biggest problems in the world of science. There should be no rectangular magnet given to children or to the scientists to start with. We always have to start with the ring magnet in any school education. Then the mindset becomes correct. This is the problem. And for us to convert from this to this has been the biggest dilemma. That's where we got lost with the gravity and magnetic fields. And we needed Newton for 20 years to unravel the whole understanding from the time when the apple fell.